The last thing we need to learn in this topic is integrating trig, and then some applications to go with that. But integrating trig is what it's all about. So these are the formulas, and you've got to be careful because the minus sign is kind of in a different spot to when you're differentiating, so don't get them mixed up. When you are integrating sine, the formula says that you want to have the derivative of whatever your function is in the front, and then that will integrate to be a negative cos of the function plus c. Now, if you don't always have the derivative function in front, I will show you how to get around that. But that's the one, this is the form that's on your formula sheet. Cos will go to sine, and sec squared, because when we differentiate, tan went to sec squared, so integrating sec squared is going to go back to tan. Okay, so first question. Find the area between y equals sine x, the x-axis, from 0 to pi. Now, the sine graph looks like this. Okay, there's my sine graph. And my intercepts here, this would be pi, and this would be 2 pi. So I'm asked to find the area from 0 to pi, which just means that I want this first section in there. Okay, it's above the x-axis, so that means that it will be positive. So let's write down area equals, it will be the integral from 0 to pi of sine x and dot dx. Now, using the table at the top, sine integrates to negative cos. Okay, now if you want to worry about the function part, my function is x, and the derivative of x would be 1, so it is fine. This is the most simple type, the most simplest function that we can have. Okay, so sine will integrate to be negative cos of x between 0 and pi. Then you are going to sub in. We have negative cos of pi, minus minus will make a plus, cos of 0. Cos of pi, or just type the whole thing into your calculator as long as it's in radians. But cos of pi is negative 1, so it is negative 1 plus 1, because cos of 0 is 1, if you're doing it without the calculator. Or you can just type it in, like I said, with the calculator, and your final answer would be 2 units squared, since it is area that we're after. Question 2, this is just evaluating a bunch of integrals, practicing integrating our trig functions. So, integrating cos. Again, the function is an x, so the derivative of the function is a 1, which would be in front. So, we are looking at our integral table, and cos integrates to what? Sine. So we put square brackets in, cos becomes sine of x between 0 and pi. Okay, then we just sub in sine of pi minus sine of 0. Again, in the calculator, as long as the calculator is in radians. What does it equal? Just 0. Yes. Now, the reason for that, I'll just show you graphically while some people are catching up. The cos graph looks like this. Okay, and if we are integrating, this would be pi here, 2 pi up there. If we are integrating from 0 to pi, we're doing that part plus that part. And now, we weren't told to find an area, but because part of it is above and part of it's below, those two areas are cancelling each other out, which is why it's giving me an answer of 0 when I evaluate the integral that it asked me to evaluate. Okay? Let's do B. We are integrating sec squared. So sec integrates to, or sec squared, sorry, integrates to tan. So it will be tan of x between 0 and pi on 3. Sub it in. Tan of pi over 3 minus tan of 0. It's just root 3. Well done. Okay, so they're the nicest ones you're going to see. Let's make them a little bit harder. Question C. Integrating between pi and 2 pi, sine of a quarter x. Now, if we were looking at our formula, the formula says if this is my trig function, I need the derivative of this out the front. Okay, and the derivative of that would be a quarter. So if I do it according to the formula, I would rewrite my integral so that I have a quarter here, sine of a quarter x. Okay, there, that's the f dash x, sine of f of x, the formula that we have on our formula sheet. But I can't just add this quarter in here randomly. I have to compensate for what I've done by timesing a 4 out the front. Because the 4 and the quarter would cancel each other off again to be back to this. But this part here is now in the form of my formula. Okay, so now I can integrate. The 4 is going to stay out the front. Using the formula, sine integrates to negative cos, so negative cos of the quarter x, the original function, between pi and 2 pi. Okay, so now we sub in. We have 4 out the front. We're going to have negative cos of a quarter times 2 pi would be pi over 2. And then minus, and a minus would make a plus, cos of pi over 4. In the calculators in radians. You typed it in? What did you get, Tyler? 2 root 2 is perfect. Yeah, so as long as your calculator is in radians, you can just type that in. Okay, D. Like last time, I need to modify my integral. Because I have sec squared of 2x plus pi, what is the derivative of my function? 2. So I need a 2 here, which means I'm compensating for that by putting a half out the front. But at least now this stuff in here is in the right form for me to integrate. So the half will stay out the front. I'll open my square brackets. Sec squared integrates to tan of the original function, which was 2x plus pi. This is between 0 and pi over 2. Oh, pi over 8. I wrote that down wrong. Thank you. Pi over 8 there and pi over 8 there. Thank you. All right, let's sub those in. We have a half bracket tan of 2 times pi over 8 would be pi over 4 plus pi. Then minus tan of 0 plus pi would just be pi. Sorry, was that the answer? Nope, wasn't the answer yet. Again, calculator in radians should be able to take care of that and keep it nice and exact for you. Still going? Yeah, half. So what happens is this is equal to 0, tan of pi and 0. That one there is equal to 1. So just 1 times the half, which is the half. Okay, let's make it a little bit trickier again. Remember that tan of x equals sine of x over cos of x, because none of our formulas tell us how to integrate tan. We do sine, cos, and sec squared. Okay, so if we want to integrate tan, we break it into its sine and cos components. Okay, then, and you also could do the same thing with cot. If you needed cot, that's just cos over sine. And then you would use our logarithm integration rule. If I have function on the bottom and its derivative on the top, then it integrates to be log of whatever the function is. So I won't spoil it. We're going to do it down here for cot and tan, using the logarithm to help us integrate. So first of all, we're asked to do cot. So cot is the same as cos of x over sine of x. Okay, now I have to start with my denominator and differentiate sine. Differentiate. Don't confuse it with your integrate. If I differentiate sine of x, look on your sheet, what do you get? Cos of x. So the derivative of that is that. That means it's perfect. It is perfect the way it is. So if I want to integrate it, it becomes log base e of the absolute value of the function on the bottom, which is the sine of x. And you should add a c because that's an indefinite integral. Let's do it again for tan. Tan is sine of x over cos of x. This time, my function on the bottom is cos. What is the derivative of cos? Negative sine. So I have to do a little bit of fiddling. If I have cos down here, I need this to be a negative sign there, which means I'm going to have to put another negative sign out the front because I need them both to really be equal to a plus. Okay, so now the part that's after my integral sign is in the right form. Negative sine of x is the derivative of that. Okay, so this minus out the front will stay. It will integrate to be log base e. I'm just going to write ln this time to save myself a couple of extra letters. So ln of the absolute value of cos of x plus c. Yeah? So our other rules can come in handy as well. Question 4. The derivative of a function is y dash equals cos of x, and the graph of the function has a y-intercept at 0, 3. Find the original function f of x, and then find f of pi on 2. We are working from the derivative, and we want to go back to the original function, which means we're integrating. Okay? So if I want to find out what y is, it means I need to integrate the cos of x, because it's the derivative. If I integrate it, I'm going backwards to the original. Okay? How do we integrate cos? Back to your formulas. It is sine. So it becomes sine of x and plus c. It's an indefinite integral. All right, now I'm given some information. It says that this graph, or this equation, y equals sine of x plus c, has a y-intercept of 0, 3. So I can sub that in to help me find my constant. So sub 0, 3 in. So that will be 3 equals sine of 0 plus c. What's sine of 0? 0, because the sine graph starts at the origin, right? So this is 0. So c is equal to 3. My equation, therefore, is y equals sine of x plus 3. All right, still not done, because after I find the original function, so I've done that, then find f of pi over 2. So I'm now going to sub in, I've used y equals instead of f of x, but that's all right. I'm going to sub in that x is equal to pi over 2 to find that last value. So that will be, I'm still calling it y, I'm not going to change now. It'll be sine of pi over 2 plus 3. And you type that in. So sine of pi over 2 is 1. 1 plus 3, that whole thing is just equal to 4. So y is equal to 4. Yeah, well. Oh, yeah, so they are interchangeable. The only reason was because it said f of x up here, that maybe I should have done it in f of x instead, but they mean the same thing, so I'm happy with it that way. Anyway. Okay, question 5. Use the chain rule to differentiate cos power of 5 of x. The chain rule is used when we have brackets to a large power. So I'm going to write this down as y equals, and this says differentiate, by the way, when we're integrating is what this topic's meant to be about, but sometimes we differentiate to help us learn how to integrate stuff. Okay? So I am differentiating cos of x all to the power of 5. I'm putting it in the brackets, I'm putting it into a form that is familiar. Now to differentiate something with a bracket with a high power, the chain rule says you bring the power to the front, you multiply by the derivative of the bracket. What is the derivative of cos x? It is sine, kind of, negative sine. So we're timesing by negative sine of x, and then we keep our bracket and we subtract 1 from the power. Okay, now if I tidy that up a little bit, you'd move the minus out the front with the 5, so minus 5, sine x, and then you'd move the cos power 4, you'd move the 4 back above in the shortcut way to write it. Okay, so if I can differentiate this to get to that, here comes part B. Hence, find the integral, and here's the sine x cos the power of 4x. That's, without the minus 5, that's this part. Okay? So normally we wouldn't know how to integrate that necessarily without doing some other fancy techniques. But if I've just differentiated it, if I can get the minus 5 in front, then I can reverse it back to what it was before. Okay, so this is what I want. I want to integrate between 0 and pi minus 5 sine x cos 4 of x. Because that's what I just got when I differentiated. But I didn't have the minus 5, so I'm going to fix that by timesing a minus 1/5 out the front, because that minus 1/5 and the minus 5 would just make a 1, which is what my question was. Yes? Okay. Now this part stays. This, because that was my derivative, that will just go directly back to the original, which was cos to the power of 5x. So it is minus 1/5 out the front. The stuff in the integral becomes cos to the power of 5x in square brackets between 0 and pi. Now, it doesn't matter if this minus 1/5 is in the bracket or out the bracket. Works the same either way. I've put it in the bracket this time. And sub in from our square brackets. We have minus 1/5 cos of pi to the power of 5. You have to put cos of pi in brackets to the power of 5 to put that into your calculator. Okay, then minus minus makes a plus, 1/5 cos to the power of 0 to the power of 5, which that one will be equal to 1. Okay, so type it all in, and we get, nobody knows, 2/5. Excellent. These calculators really make your life easy, you know. We would have had to do all sorts of fun things if we weren't using these. All right, question 6 is about the reverse chain rule. So, if I hadn't done that, let's differentiate it first and then go backwards, the reverse chain rule would have been our other option to try and integrate this sine x cos the power of 4x. This is a reminder of what the reverse chain rule is. Okay, this is the one on your formula sheet. Start in here. If you have a function to the power of n, now my function is the cos x. It's the one that has the power on it. Okay, so here's my function to the power of n. I need the derivative of that function out the front. What's the derivative? My function was cos x, like I said. What is the derivative of cos x? Negative sine. So I'm going to rewrite this to be negative sine x cos to the power of 4x, so that I have my derivative in front of my function. Of course, if I add a minus in, got to compensate for it, put a minus at the front, and make sure it's the same as the original. Okay, but this part is now ready to do my reverse chain rule. So if it's in the right form, which it now is, all I need to do is take my function, which is the cos x, add 1 to the power, and divide by that power. Okay, so it becomes, the minus is sitting out the front, and my chain rule becomes cos to the power of 5x over 5 plus c, which is, if I go back here, is what I had in here when I did it with my other method. Here's my minus 1/5 cos 5 to the power of x. I don't have to sub in the values this time like I did in the last one. Okay, so that's it. That is the end of 7D.